Matrices by Isabel and Maggie. A matrix is a rectangular array of quantities or expressions in rows and columns that is treated as a single entity and manipulated according to particular rules. Here's an example of a matrix. It's also considered a two-dimensional array of numbers. The operations defined for matrices make them special. First, we're going to talk about dimensions. They're basically the same as if you were going to measure a square. The first one would be 2 by 1 because there is 1 in each row and 2 in each column. So 2 by 1. The next one would be 5 by 1 because there's 5 in each column and 1 in each row. So 5 by 1. The last one would be 3 by 2 because there's 3 in each column and 2 in each row. 3 by 2.
Now we're going to talk about multiplying matrices. Our first problem over here is D equals -1, 0, 4 in our second row, 2, 0, 0. And F equals -1, 1, -1, 3, 2, 4. So what we're going to try to find is H, and we need to find DF equals H. So you see we have our H grid right here, and we don't necessarily need to use all of these columns. It might be smaller. We just put those there. Now, H11 would be our first row across here, and in D, and our first column in F. So, how we're going to try to find this is we're going to need a -1, 4, 0, and 4, and -1, -1, -1, and 2. We'll put them down here in our problem, and we'll have -1, 0, and 4 times -1, -1, 2. Okay, so to find H11, which is referring to, again, the first row across and the first column down, we're going to need to start over here with the first number in these parentheses, -1. And we're going to move over here to the first one over here, -1. So you see here we're doing -1 times -1. Okay, so moving on to the second number right here, 0, in this parentheses, we're going to multiply that by the second number over here, -1. And that will be 0 times -1. And then we need to add the third and final number in each parentheses, 4 and 2. And so we have our problem here, -1 times -1 plus 0 times -1 plus 4 times 2. So we know -1 times -1 is 1, 0 times -1 is 0, and 4 times 2 is 8. So 1 plus 8 is 9. And that is H11, which goes right here in our matrix. Now that we found H11, we need to find H12, H21, and H22. The way we do this is H12 would be, again, the first row across and the second column down. And H21 would be the second row here and the first column down. And H22 would be the second row and the second column. And you would use similar methods of multiplying to find these.
Like these. And then you would get those.
The remaining 3 numbers, 15, -2, and 2.
Yep.
Okay, moving on to our second problem, D and A, we're going to have to let D, A equal H. So moving down here, we're going to have H1, 1. H1 would be the row here, and then the other one would be the column down here. So we would have 2 times -2 equals -4. Okay, now that we found H11, which is down here, we need to find the remaining 5 numbers in the matrix. So we will have to find H12, H21, and H22, and H31, H32. So to find H12, again, our first row and our second column, and then, okay, and for H21, we'd have the second row, which is 3, and the first column, which is -2. H22 would be 3, again, the second column, row, my bad, and the second column over here, -2. H31 would be the third row right here, 4, and the first column, -2. And 3, 2, our final point for H, would be the third row, again, 4, and the second column, 2, -2. Stop it. Now that we know what our h's are, our matrix will look like this when we've completed all the multiplication.
Matrices! Thanks for watching. Stay tuned for next time.